Welcome to Networks Professionals.
Welcome back to The Explainer. We're literally moving from a world where computers just, well, crunch numbers, to a world where they actually create. Today, we're decoding the source material on generative AI to understand exactly how this technology is reshaping our world right before our eyes. So let me ask you this. Can a machine possess human creativity? I mean, for decades, the answer was just a simple, resounding no way, right? Creativity was kind of seen as the ultimate human firewall. It was the one thing a microchip simply couldn't touch. But recent breakthroughs have fundamentally challenged that assumption. And honestly, that's exactly what frames our entire exploration today. Okay, let's dive into this. What are we actually talking about when we say generative AI? Well, it's a specific subset of artificial intelligence, sure, but the absolute magic word here is create. It's designed to generate entirely new, original content by learning complex patterns from absolutely massive datasets. So it's not just looking at a painting and telling you who painted it. No, it's actually picking up the digital brush and painting something completely new. It's actively mimicking human creativity. Here's our roadmap for today. 1. What is generative AI? 2. The creative AI toolbox. 3. Looking under the hood. 4. The big benefits. And 5. Challenges and limitations. All right, starting with section 1. What is generative AI? Moving beyond analysis to creation. For years, traditional AI was pretty much all we knew. Analyzing and classifying existing data. Think of a spam filter checking your emails, or an algorithm recommending your next movie. It just looks at what's already there and categorizes it. But generative AI, it completely flips the script. It uses deep learning to create entirely novel outputs. We're talking about fresh text, completely original images, newly composed audio, dynamic video, and even functional software code. It's basically the difference between being a music critic and being the actual composer. Moving on to section 2, the creative AI toolbox, categorizing the generation explosion. And this brilliantly illustrates what a massive multimodal revolution we're in right now. I mean, look at the scope here. In text, titans like ChatGPT and Claude are churning out stories and articles. Visually, DALL-E 3 and Midjourney are turning simple text prompts into just stunning art. Then we have platforms like 11 Labs and Suno creating incredibly lifelike audio and music tracks. Tools like Sora are conjuring dynamic video literally out of thin air. And platforms like GitHub Copilot are actually helping developers write functional software code. It is an absolute explosion of generation. Section 3. Looking under the hood. The deep learning models powering the magic. Let's pop the hood here. The first engine component we really need to understand is the transformer model. I like to think of these as the storytellers. You see, transformers are specifically designed to understand the structure of data and then predict the next likely element in a sequence. So when you type a prompt into a text generator, it's using a transformer to weigh the context of your words and then mathematically predict the most logical, context-aware sequence of words to output next. It's this incredibly sophisticated pattern matching that honestly feels remarkably like human thought. Let's move to the visual realm and see how this builds, because now we have diffusion models, or as I call them, the sculptors. The way they work is just fascinating. They're actually trained by taking a perfectly clear image and slowly adding digital static, or noise, until the image is completely unrecognizable. Then, the model learns how to reverse that exact process. So when you ask it for an image, it literally starts with a canvas of pure, random digital static and chips away the noise, pixel by pixel. It sculpts it until a brand new, pristine image is revealed. And then we have generative adversarial networks, or GANs. This is basically an incredible mini-narrative playing out right inside the computer. GANs consist of two separate neural networks locked in this fierce, ongoing competition. Think of one as the forger, who's constantly trying to create a fake image that looks perfectly real. The other is the detective, and its whole job is to spot the fake. And they just battle back and forth millions of times. The forger gets better at creating synthetic data, and the detective gets sharper at spotting flaws. They do this until eventually, the forger produces synthetic data so incredibly realistic that the detective, and honestly, us humans too, can no longer tell the difference. No way, right? Which brings us to section 4. The big benefits. How this technology accelerates human output. So the crucial point is how these tools actually empower us, because the impacts are profound. We are seeing majorly boosted productivity by automating tedious writing and visual generation tasks. That frees up human time for actual high-level strategy. Businesses can now instantly generate customized marketing messages and designs tailored to highly specific audience segments. But perhaps the most impactful area is accelerated research. Scientists are actually using this right now to create synthetic data for models, simulate clinical trials, and even discover new drug molecules at just a fraction of the traditional speed. And finally, democratized creation. You don't need a massive budget or a decade of technical training anymore to produce professional-grade art, music, or video. The barrier to entry has been permanently lowered for all of us. Finally, Section 5, Challenges and Limitations, the necessary guardrails for AI. Now, what's really interesting about this slide is the direct tension it shows. Against all these massive benefits we just talked about, we face some very critical risks that the industry is actively grappling with right now. First up is hallucinations. Because these models essentially predict what sounds right, they can sometimes confidently generate completely inaccurate or false information. Second is bias. These models learn from vast amounts of internet data. That means they can easily replicate or even amplify existing human biases found in that training data. And third is the extremely complex gray area of copyright and ethics. We've got ongoing debates about models being trained on copyrighted materials without permission, plus the very practical questions regarding the authenticity of content, especially when we can no longer simply trust our own eyes and ears.
Which leaves us with this final thought. As transformers, diffusion models, and GANs get better and better at flawlessly mimicking human creativity, where exactly is the line between algorithm and artist? It's a profound question, and honestly, it's one that will define the next decade of human innovation. Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I will see you next time.
Thanks for watching.